All right. So now we get to the very meta part of psychology where we're learning about learning. Thrilling. Okay, so we're going to start with classical conditioning, which I'm sure most of you have heard of, if not learned about, when you took regular psychology. So we'll start with the question, what is learning? So by definition, learning is the process of acquiring through experience new and relatively enduring information or behaviors. So we learn all sorts of stuff all the time, right? We learn things in school, but we also learn associations. Like our minds will naturally connect events that occur in sequence. We basically anything that you remember is something that you've learned. Fun fact, if you give people a red pen, which is associated with marking errors, rather than a black pen, they will spot more errors and give lower grades when they're correcting essays. This is why I don't grade in red pen, so you're welcome. All right, so there's this thing called habituation, which is decreasing responsiveness with repeated exposure to the stimulus. We learned about that with sensory stuff, but it also works for learning because you learn that something is not threatening, such as this scarecrow. Classical conditioning, which was found and discovered by Ivan Pavlov, is a type of learning where we link two or more stimuli. So you basically have this like automatic association. When Pavlov was doing his experiment, he linked a stimulus of a tone, like a bell, in order to get dogs to salivate, to drool. So essentially what he did is he noticed here that dogs drool when they see their food. So the food would be the unconditioned stimulus, or the US. The salivation, the drooling, would be the unconditioned response, or the UR. So then he was looking, okay, if I wanted to teach the dog to drool on the bell, if I do that just randomly without teaching the dog anything, the bell is a neutral stimulus, and the dog will not salivate. Like, why would a dog salivate at a bell? In order to teach the dog, you would pair the bell with the food. That becomes the conditioned stimulus, and you still get the drooling. So after conditioning, the bell does elicit drooling. Okay, so here's an image. Basically, you have two related events, lightning and thunder. Lightning isn't as scary, like, physiologically to us as thunder, and so when we hear the thunder, we wince, right? We react. However, we learn that lightning comes with thunder, and so then when we see lightning, we still get scared. There's some vocab that you have to know here. First is neutral stimulus, which is a stimulus that elicits no response before conditioning. Unconditioned stimulus, which is a stimulus that naturally triggers a response. Unconditioned response, which is an unlearned natural response. Conditioned stimulus, which was originally neutral, that is then associated with the unconditioned stimulus. And the conditioned response, which is a learned response to a previously neutral stimulus. So this is kind of like the before, this is the after. When you're using the terms, the natural things, the before, is your unconditioned stimulus and your unconditioned response right here. Your learning is when you pair the unconditioned stimulus with the neutral stimulus to get the unconditioned response. This is really annoying that it's backwards. And then the learned would be the conditioned response the conditioned stimulus leads to the conditioned response. More vocab. First is acquisition. Acquisition is the initial learning. Then extinction is the unlearning, right? So if you're looking at this graph, right, x-axis is time, y-axis is the strength of the conditioned response. It takes a while for someone to acquire a conditioned response, and then it drops off faster, right? You lose that conditioned response faster than you would gain it. There is something called spontaneous recovery, which is the reappearance after a pause of an extinguished conditioned response. So let's assume that you've unlearned this one. You can recover it if something like primes you to do so. And there's a couple of other vocab terms. Generalization is the tendency for stimuli similar to the conditioned response to elicit similar responses. So like maybe you're afraid of snails, you might also be afraid of a tape measure, of a tape dispenser, because it looks kind of like a snail. There's also discrimination, which is the learned ability to distinguish between a conditioned stimulus and an unconditioned stimulus. So this would be someone who's afraid of snails being like, but I'm not afraid of that tape dispenser, ha. Okay, this is some more vocab that I'm not going to go over, but you should learn. That is basic conditioning. You can also get to higher order conditioning, where you use the conditioned stimulus in order to condition another neutral stimulus. So this would be, okay, let's say the cat drools at food, right? So you would pair the electric can opener and the food is going to make the cat drool. So now the electric can opener makes the cat drool. Then the cat finds out that the food is kept in a squeaky cabinet. So now the squeaky cabinet door is the second order stimulus to the electric can opener, which is the conditioned stimulus. So now the squeaky cabinet door also makes the cat drool. This kind of led into something called behaviorism. So this guy, John B. Watson, he founded behaviorism. He had the idea that human behavior is the result of conditioned responses, that everything a human does has been conditioned. And he was a little creepy. He said, give me a baby and I can make any sort of man. Basically that like he just has total control, which just creeps me out. I don't know about you. So he took this baby named Little Albert and he conditioned him to fear furry things. And that got to the point where like Little Albert was afraid of Santa Claus. He was afraid of fuzzy blankets. He was afraid of literally anything fuzzy or furry. Okay, so John Watson thought that classical conditioning could like achieve all, right? It was like the be-all end-all of learning. There are some limits on classical conditioning. So one is preparedness, which is a biological predisposition to learn associations that have a survival value. So you are going to learn those things faster than, say, an association that doesn't have a survival value. And John Garcia challenged the idea that all associations can be learned equally well. Some are stronger than others. Garcia learned this by looking for taste aversion in rats. So they could be conditioned to not taste something yucky, right? Okay, fine. But they could not be conditioned to aversions of sights or sounds. So maybe it's better to learn via taste for rats than sights or sounds. There are also cognitive limits on classical conditioning. So this guy, Robert Rescorla, he studied animals and he said that animals can learn the predictability of an event, not just the consequence. But those additions can also influence their attitudes. Things with positive associations are usually viewed more positively. So basically, our cognitive self is going to influence how we're conditioned or how we experience conditioning. All right, so there you go. Woohoo! Classical conditioning.